Okay, we are going to work with method of integration by parts. Integration by parts. Integration by parts is a technique that can be applied to a variety of functions, and specifically it's useful for integrands that working with products of algebraic and transcendental functions. For example, if we have integral x ln x dx, okay, another example with ex, let's say, can be x squared e to power x dx. And then, for example, e to power x sin x. Okay? So here we have and algebraic expression and transcendental function, algebraic expression, transcendental function. Okay. Sinus x dx. So integration by parts says if u and v are functions of x, and v is a function of x, then, and they are derivatives, these functions, and have continuous derivatives also, then we can insist that integral u dv is equal uv minus integral. Let's take first example. Integral x e to power x dx. So our goal is we need to represent our integral in the form of u dv. Okay, so there are several ways to represent as u dv. Let's see. First, I can represent here, for example, as an integral x e to power x dx. So where e is going to be my x, my u, I'm sorry, going to be my u, and e to power x dx is going to be my dv. Next version I can use, it's going to be e to power x will be act as my u, and x dx will be my dv. Okay, put in parentheses. Next, the third version of the combination, it can be, if I put here 1 and then x e to power x dx, so this will be my u, and this is going to be my dv, the whole parenthesis. And lastly, it can be this case. Let me move a little bit here. The case where integral, I will take as a u x e to power x times x, and I will have dx. So x and e to power x will be u, and dx will be v. Now, how to figure out which one can fit the best, because it's a product, so you can take all kinds of combination, and we took it, all possible combination. How to figure it out? First of all, we know that we need to find out, we need u and we need du, we need v and we need dv, right? So if we are given, we are going to be given practically u, and we are going to be given dv, which means that du we need to calculate and v we need to calculate. So what does that mean? So that means given u and dv from the integral, then we will get from u, we will get du, and from dv we will get v. From, as you can see, the challenging one is going to be this one, from dv to get v. Why? Because it's going to go through integral. While from u to du, we are going to use derivative. From dv to v, we are going to go through integral. Therefore, I am going to focus what is going to be my dv. Try to choose as simple as possible, so to avoid complicated calculation of integral. So obviously in these cases, let's say this third and fourth one are falling out because there is no change here. It's going to be original one again. And the last one, it's still, I will end up with complicated case because once I take derivative and do it, it's going to get through long story. Now we have left first one and second one. One at glance you can see that it could be successfully in first one and second one here, because you have ex dx, integral is going to be ex, it's pretty straightforward, and x dx it's going to be also easy, because integral x dx it's going to be x squared over 2, right, the second one here. But the thing is, let's not to forget that later on we are going to use this v that we'll get from here. We're gonna squeeze under this integral, which is gonna bring me again back to original one. Let's say if from this second one, from this one, let's say, if assuming my dv is x dx, right, then v is going to be integral x dx and x squared over 2, right? Seems to me it's pretty straightforward. But when I plug into this integral v du, it's going to be equal v, it's here x squared over 2, and du, it's going to be, if my u is e to power x, then du is going to be e to power x and then dx, which will bring us back exactly to the first original integral, right? With the 1 over 2 constant added to it. So we will be back to square one, and with we got here also x squared. So this one also not working. Be careful, when at the beginning looks simple. So what we're gonna do now, we're gonna choose the first one, this one, to work with. So let's start working. For this first one, our u is going to be equal x, which means du is going to be dx. Yes? Okay? If our dv is e to power x dx, then v is going to be equal integral of dv, right? Which is going to be equal integral of e to power x dx, that is equal e to power x. Constantly have hard time with having decent integral sign. Okay, so once we have it, now let's start working on it. So integral, we know that integral u dv is equal uv formula minus integral v du. Now, well, let's plug. So integral x e to power x dx, it's going to be equal u, it's going to be my what? X, right? V, it's going to be my e to power x minus integral. V is going to be e to power x, and du is going to be dx from this piece, right? From this and result is going to be x, x e to power x minus e to power x and plus c. Okay, and we are done here. Okay, moving to next example. Now we're going to use x squared natural log x. Okay, x squared natural log x. This was number 1. Let's solve number 2. Integral, we have x squared natural log x dx. So, since x squared is more easily in this integral can be integrated than logarithm x, right? And also derivative of natural logarithm x is simpler, right? So therefore I'm going to do this. My dv, I'm going to rewrite this way. Natural log x, x squared dx. And this is gonna be my dv. And this is gonna be our u. Also, I want to invite your attention. When we use the formula, integral u dv is equal uv minus integral v du. So don't forget, here we're going to take another integral here. So you have to remember that also and try to make it a less complicated case for your integral, so it will be easy on you. Okay, if you take logarithm x dx, it's going to be logarithm x, right? But having the v, you will end up again x some degree and logarithm x also. So it will go backwards. Therefore, this is going to be the best the choice. If you wish, you can try take x squared as your u and logarithm x dx take your dv, and you will see what I'm talking about. You will get stuck. All right, so logarithm x is our u. Let's write down u du v dv. So if my u is logarithm x, okay, du, it's gonna be 1 over x dx. Let me leave some more space between them. Okay. So 1 over x dx, and we have dv is given, right? dv is x squared dx, and v is going to be equal integral x squared dx, which is going to be x cubed over 3. So let's solve it. Let's integrate by parts. Okay, integral u dv is equal u times v minus integral v du. Okay, so integral x squared natural logarithm x dx is equal x cubed over 3 natural logarithm x minus integral x cubed over 3 1 over x dx, right? Okay, so we substitute it. Now we are going to simplify. This is gonna be equal x cubed over 3 natural log x minus 1/3 comes out, obviously, and we are going to have this x is going to be gone, and this 3 is going to become 2, and we are getting x squared dx. See how beautiful it's becoming. It's no headache with integral, very easy, solvable. So it's equal x cubed over 3 natural log x and minus 1/3 times x cubed over 3 and plus c. So which is equal x cubed over 3 natural log x minus x cubed over 9 plus c. All right. You can check the answer by taking derivative, okay? Take this answer, from this, take d by dx, the whole this thing, you can do. Let me see. Can take d by dx, all right? And you will see that you will get backwards the answer, which is going to be x squared plus natural log x. The original expression we have here, x squared natural log dx, if you take derivative. Well, okay, since I started, let me do it. It's going to be equal x cubed over 3, 1 over x, right? Now, derivative of log x, plus log x times x squared, right? And minus x squared over 3. So this is going to be equal x squared natural log x. Okay, which what we have. So the answer here for this question is going to be x cubed over 3 natural log x minus x cubed over 9 plus c. Okay, moving to next question, number 3. So we have integral x squared sine x dx. So the fact is, in this case, both and x squared and sine x are equally easy to integrate. But the derivative of x squared becomes much simpler, while derivative of sine x does not. So therefore, I'm going to choose dv as my sine x dx, and x squared is going to be my u. Okay, let's do it. U du v dv. So u is equal x squared. So du, it's going to be obviously 2x dx. Okay. Next we have dv, which is sine x dx. And getting v is equal integral sine x dx, which is going to be negative cosine x. All right. Now let's do integration by parts produces. The integration by part produces the following. So we are getting x squared sine x dx, that is equal. So uv, right? We are going to use first uv. My u is x squared. My v is cosine, negative cosine x. All right. And plus integral 2x cosine x dx. Okay. Okay. So we successfully wrote down the formula. So what did we get? We ended up with 2x and cosine x dx, which is again form of product, right? So which means I'm going to do one more integration by part for this one. Second, this integral I'm going to write down, you will see. So I'm changing the color so you can see here. Integral 2x cosine x and dx. So I'm going to integrate one more time. dv, I'm going to choose dv is going to be equal cosine x dx Okay, therefore v is going to be equal integral cosine x dx, which is going to be equal sine x. All right, u is going to be equal my 2x, right? And du is going to be equal to dx. All right, so 2x cosine x dx, it's equal 2x sine x actually I can rewrite much better. 2x sine x minus integral 2 sine x and dx. All right, so from here we have 2x sine x and plus 2 cosine x and plus c. Yes? So once we integrate it again, the second integral, so from here, once we combine the whole this piece, we are getting integral x squared sine x dx is equal negative x squared cosine x plus 2x sine x plus 2 cosine x and plus c. And this is our answer. So I would like here to warn you about some common mistakes students do. When you are making repetition of integration by part, you need to be very careful not to interchange the substitution. Okay, what do I mean? Look, first time my dv was sine x dx. See, here also I had cosine x dx. So you cannot switch, let's say, second time, dv have 2x dx, let's say. Let me show you what I mean. I'm going to change the color so I can show you. So if I would put, let's say, I had u is equal x squared, right? Originally here. U is equal x squared and dv was equal sine x dx. Yes? Okay. This is the mistake I'm warning. So second time, let's say, instead of doing a similar substitution like this one, let's say, what if I would mess up and I would substitute u, I would take as a cosine x, okay? And dv, I would take 2x. You understand? 2x dx. You cannot do that. You cannot switch the elements in substitution. If you got, let's say, trig function with dx as dv, and you got algebraic expression, then when you do repeating your substitution, you have to stick to the same structure. Again, trig function with, or transcendental function with dx will be your dv, and u will be algebraic function, okay? So this will bring you to a different answer. For example, let me show you real quick. So you would get x squared sine x dx would be equal negative x squared cosine x plus integral 2x cosine x dx. Okay, so and then what I would get? Negative x squared cosine x plus cosine squared x squared cosine x, and then plus integral x squared sine x dx. So practically I broke this down to this using this substitution. Okay, obviously if u is cosine x, du it's gonna be negative sine x, and so forth. So we used it, and you can see that it took you completely somewhere else. All right. All right, moving to the one more question, and this time we're gonna work with secant. This was question number 4, right? I think. Integral secant cubed x dx. Okay. The most complicated portion of the integrand that can be easily integrated is secant square x, right? So therefore, I'm going to break it down as integral secant x secant square x. You know what? I wanted to put square in front. All right. So let's substitute our u du v dv. Okay. I'm taking my u as a secant x because I'm leaving secant squared for integration, right? It is the integration. Okay, secant x, then du is going to be secant tangent, right? Because derivative of secant is a secant tangent. Secant x, tangent x, and dx. dv, on the other hand, is secant squared x dx. So going backwards, meaning we are integrating secant square x dx, which is going to be equal tangent x. We know that, right? Integral. Because derivative of tangent is secant square, integral of secant square is tangent. Okay. So writing down. Integral u dv is equal uv minus integral v du. All right, let's write down. So integral secant cubed x dx is equal secant x tangent x, right? Minus integral secant x tangent square x and dx. Push this away. And dx. Okay? So, from here, we have secant cube x dx. It's going to be equal secant x tangent x. Rewriting here, integral tangent square x is equal secant square x minus 1, right? So we are doing trigonometric identity here, and this is going to be equal secant x and secant square x minus 1 dx. So instead of having two different names of trig functions, which would make it more complicated, so I just turn to one type. All right, what is going to be happening here? So it's going to be equal secant x tangent x minus secant cube x dx plus integral secant x dx. Okay, so let's collect like integrals in this case. This is also secant cube x dx. It's going to be very interesting solution here. I have integral secant cube x dx, and I have here integral secant cubed x dx. I can put together as a like terms, right? This way I'm going to get 2 integral secant cube x dx is equal secant x tangent x, right? And plus integral secant x dx. Okay, so from here, 2 integral secant cube x dx is equal secant x tangent x. So what is derivative of secant? I mean, integral of secant. Is equal natural log secant plus tangent. Natural log secant x plus tangent x and plus c. Okay, so this is going to be equal logarithm secant x plus tangent x and plus c. So from here, integral secant cube x dx is equal 1/2 secant x tangent x plus 1/2, right, dividing by 2, natural log secant x plus tangent x and plus c. Okay, and we have the solution, and this is our answer. Okay, so thank you for watching, and I will continue next time, and you have enough to watch and digest for now. Okie dokie.